Okay, so we're going to calculate then pH of a solution which HBr is dissolved in water, and we've got 0.045 moles of HBr, and that's going to be placed into 1 liter of water, which becomes then our HBr solution. Now, by definition, molarity, which is the concentration unit we need, is moles of solute, which is the thing being dissolved, in that case that's HBr, over liters of solution, which is what we have down here on the bottom. Okay? Once we find molarity, then we find the pH. Well, then the other thing you got to know is that HBr is a strong acid, so it's going to dissociate completely into H plus and Br negative, or if we're using Bronsted-Lowry, HBr plus H2O, H3O plus Br negative. No, I'm just showing you. Okay. So then, whatever the molarity of the acid, because this completely dissociates, every one of these I get one of these, and therefore the concentration of the hydronium or hydrogen ion. This is using the Arrhenius theory. This is using Bronsted-Lowry. Whatever the concentration of the acid, because it's a strong acid and it's monoprotic, the concentration of the strong acid is going to be equal to the concentration of the hydrogen ion in the Arrhenius system, or the hydronium ion in the Bronsted-Lowry system. Okay, so that's our concentration. That's what this is going to be, and that's how we're going to get all this. All right, so we just got to take this and divide by that. Well, that is the same number. I made it kind of easy for you. 0.045 moles HBr per liter of solution, which is the molarity of the HBr solution. Solution, which then is also the molarity of the H plus, or this is the molarity of the H3O, depending on which one of these two systems we want to use. Doesn't matter. Okay? Now then, pH is the negative log of hydrogen ions if we want to use Arrhenius, or the negative log of the hydronium ion if we want to use Bronsted-Lowry. So all we have to do is take the negative log of that number, so let's see, negative logarithm 0.045, and I get 1.346787486. We haven't talked about how to round that off. There actually is a separate set of rounding rules for logarithms and exponents. Has anybody learned the rounding rules in math? No? Okay, so what we're going to do, we're not going to at this point in the semester try to learn a whole new set of rounding rules. The problem is the rounding rules we're going to use is going to give us a little bit of, it's going to increase our error, because it's not really the way you're supposed to do it. But we're going to use multiplication and division rounding rules. I'm not going to count it against you if you didn't do it the way I do it today, because this is the first time I've told you. So since I had 2 digits in my initial measurement of molarity, I'm going to have 2 digits in the pH. I'm going to say the pH is 1.3. Huh? What? Leading zeros are not significant, right? Okay. I'm not going to count off for rounding incorrectly today. Okay? Got that? All right. Everybody get this? Nuh-uh. Oh, she must be saying, there's something else. All right. All right, so if you got the math right, okay, then you let's make it simple. Put 100 on there. You need to show all your work, but today we're going to make it fast because I'm kind of in a hurry to get on to some other stuff. Okay?